All right, hello, Fruitport High School AP Chemistry students. So this video, I want to show you everything that goes into forming an ionic bond. It's a little bit more complicated than you might think, and the steps have a little bit of review, and if this is something you don't find like super easy to understand, it's not crucial for the future development, and there's other topics that parallel this that will help you understand the big picture. So here we go, today's lesson. What goes into an ionic bond? Okay. What goes into an ionic bond? Well, our classic example for what goes into an ionic bond is to use the equation of sodium, which in natural state is solid, plus half a mole of diatomic chlorine, which is a gas, and it turns into sodium chloride, which is a solid. Okay? Now, for this to actually occur, there's actually 5 little steps that happen along the way, and I'll do each step in a separate color. Okay? So the first step is that the sodium, which is a solid, has to turn into sodium, which is a gas. Sodium solid turning into sodium gas is called sublimation. And I looked it up. The energy for this to occur is 108 kilojoules. Now, if you're like, I don't know what a kilojoule is, well, we're kind of jumping around in chapters in the book, and it's just a unit of energy, okay? The second thing that happens, which I'll do in blue, is that the sodium gas has to lose an electron to become a sodium ion, and an electron falls off for this to happen. Now, we recently just learned a vocab word for the energy needed for an electron to be removed for an ion, and this is the first ionization energy. So I looked up the first ionization energy for sodium, and it requires 496 kilojoules to do that for every mole. Okay. Now the sodium is ready to be used in the last step. So the next steps are going to talk about chlorine. Okay. So for this to happen, we have this uncomfortable fact that chlorine is diatomic. And so for us to turn chlorine gas into just plain old chlorine atom, which is kind of a radical, we have to break the chlorine-chlorine bond. And that's just called bond energy. And for half a mole of chlorine diatomic to turn into 1 mole of this, the value is 122 kilojoules. Okay. Now, chlorine has to gain an electron to become an ion. So we're going to take the chlorine that we have as gas. We're going to add an electron to turn it into a chlorine ion. And this is called electron affinity. Right? How well does atoms attract other electrons to itself? It was kind of in our notes, but we didn't spend as much time on that one as the other trends. And this one has an exothermic, so it's a negative value. And the last one, and my favorite one to bring up, is that we have lattice energy. We can now let the sodium ion and the chloride ion come together to make NaCl. And you should have just watched a video explaining that when positive and negative ions attract, we call that lattice energy. And lattice energy for ionic compounds is quite strong. Look at this, negative 788 kilojoules. All 5 of these steps occur for this red original reaction to proceed. And we show this by trying to add all these up cumulatively, and we look for things to cancel or combine. So if I add something as a product, something as a reactant that's also a product, we can cancel those out. So for instance, I see sodium gas and sodium gas. And so I will cancel those out as we add those together. And I see sodium positive 1 ion and sodium positive 1 ion way over here. I want those to cancel. Maybe I'll do a backward slash to show how those cancel. Oh, look, I see an electron as a product, an electron as a reactant. So the electrons are going to cancel also. And we got two more things. We have chlorine gas atom and chlorine atom as a gas. So I'll put an X through this to show it cancels. And chloride ions. I'll put a little squiggle like this to show it cancels here. You'll notice the only thing that didn't cancel are these two components, which are sodium solid and half a mole of chlorine gas, which is what we had in our original reactants. And the only thing that didn't cancel here is NaCl. Now, what's the real trick? Well, if we can add all these subparts, sub-steps to equal an overall step, we can add all of these energies together. And so if you were to take this plus this plus this plus a negative number and plus this negative number, we get negative 411 kilojoules. So this reaction has this energy because it's a cumulative total of all the energies of the 5 steps. Okay? For your homework assignment, you're going to have to do this, but you don't have to look up the numbers. They just gave them to you. You essentially just have to trust that if you add them together, it will add up. The only trick is you might have to use something twice. Like for instance, what if you, instead of 1 Na and 1 Cl, what if we had strontium chloride? Well, we would need, that would be SrCl2. We would need 2 chlorines, which would mean we'd have to do this brown step twice. So we got 2 chlorines in our answer. We'll do this at homework today. Tomorrow in class or the next day in class, we'll look at some sample problems to make sure you understand it. Okay? Cheers. Have a good day.